popularity at my college. Before we dive deep into the skies in this exciting session, let me introduce a very special initiative that's going to enrich your astronomical journey in NASA, the National Astronomy Network of IAPT. NASNI is a national platform initiated by the Indian Association of Physics Teachers (IAPT). It is designed to connect new sky gazers like many of you with astronomy experts, planetarium professionals, astrophysicists, and even popular public figures in skyward. Because sky gazing becomes more meaningful when we share it with mentors who can guide us, with tools and events that inspire, and with a community that shares our excitement. NASNI is that bridge between the beginner and the expert, between curiosity and knowledge. So, dear friends, NASNI is here to guide and grow with you. Welcome to our network. Welcome to NASNI. It's my absolute pleasure to host this session. I'm very grateful to Hemant sir for giving me this opportunity. At NASNI, try to do more than just exchange ideas. We try to pause, reflect, and connect with people whose journey remind us why science, education, and empathy must go hand in hand. As Albert Einstein once said, education is not the learning of facts, but the training of mind to think. Today's speaker embodies that spirit, not just in words, but in practice. It's my absolute pleasure and honor to introduce Mr. Gopal Mandal, an educator, physicist, and someone whose journey bridges the world of academic excellence and impact. Mr. Gopal completed his MSc in physics from IIT Kharagpur in 2012, an institution known for shaping some of the finest scientific minds in the country. After graduating, he entered higher education as an assistant professor of physics at Chameleon. In 2019, he made the decision to leave college level academia and devote himself to the school education system. Since then, he has been working as a physics teacher at Vivekananda Adarsha Vidyalaya, a government school in rural district. There, he brings the same academic rigor to classrooms, even lacked basic facilities, but never lacked curiosity or potential. His teaching is not powered by projectors or lab, but chalk, conviction, and an unshakable belief in power of young. In the time when many choose prestige, Mr. Gopal chose purpose. In a world where impact is often measured by accolades, he chose to make a difference quietly, where it matters the most. And today we have this rare opportunity to hear from someone who teaches those very students, lighting fires of curiosity in places where others might not even look. His journey is not just inspiring, it's a call to all of us to reflect on what science and education truly stand for. So, without any further time, please join me in warmly welcoming Mr. Gopal to NASNI's stage. Sir, I cordially welcome you, and the floor is all yours.
Good evening, and thank you very much for this introduction. And also, I want to thank Professor Hemant Kumar, a senior professor, who invited me, and I am feeling very honored for this invitation. Also, I want to thank all the listeners here for your valuable time. Now, directly, I want to focus on my lecture. I think this is not a type of lecture. This is a just a discussion with. Okay, this is experiment one. Actually, I think you are seeing this experiment one, measurement of the earth cone distance.
Yes, now we can see full screen.
Okay. Thank you for this cooperation. So, this very simple experiment, we know the actual distance between the earth and moon. and we know this, but actually this will be very pleasure for the class 10th 11th student if they can measure at their home roughly. So just you need a the small telescope. Small telescope means this is a just you can use a finder scope also, means a 6x or 5x finder scope also available for with a telescope. So you can attach a small telescope on a platform, and actually there will be a attachment with a protector. So this mini clinometer in clinometer gives you this result, and we sorry. So I think everyone can be able to build this setup, and just we have to measure the angular size of the moon with this setup. So this will be better if we put a crosshair on the eyepiece of this small telescope to for the perfect measurement. So there is a illustration, uh, a astronomer viewing the moon with the naked eye. So just uh, put the clinometer, and this clinometer has a small weight mentioned here as a red line, means this is a movable thread with a heavy stone or something. So if we focus, or if we target the moon, actually moon one side of the moon, means if we fixed our crosshair at one side, then at that time we have to record the angle, and again tilted up the telescope, and the just feed the crosshair at upper edge of this moon. So we can roughly get the angular distance or angular diameter, just difference taking the difference of two data. So here roughly this is my data. Actually roughly this is 0.5 degree. So just change the degree to radian, and for a small angle we know theta equals to d by d, just like a sin theta equals to tan theta for small theta. So roughly we have the mm, very close value, 3 lakh 3 lakh 98,000, and we know actual value is 3 lakh 84,000. So actually this is roughly measurement, but result is very close to the actual result. So a student of class 9, 10, 11, 12, also any people interested in astronomy can perform this experiment, and they can enjoy, and we get the better result doing the same experiment again and again, and using the uh, good telescope with a tripod, which have a setting circle there. So we can directly measure the angle from the setting circle. um, so we can perform in better way as you choice, as your choice. And so this is a very simple experiment, but I think uh, a lot of people have a telescope did not perform this experiment also. So I just saying, do this experiment. And a second thing is, we know the orbital path of the moon is not circular, elliptical. So the close distance is varying. So the angular size also may be varying for the position. At one closest at closest position, this is 0.56 degree, and at apogee position the angular size is 0.49 degree. So you can mm, measure this angle also. Also you can measure the distance at apogee and perigee also. So this would be also second step of this first experiment. Now we are going to measurement of a size of the crater on the moon. this image I have taken with my telescope. This or 5 inch or means 127 millimeter reflector telescope with my smartphone. So just if you have a small telescope and if you are passionate with capturing the uh, photo of this moon, just like this, not too much clear or too much magnified. This if you have a this potential, then you can measure the size of the crater, means diameter or length, height, etc. So just you need a ruler. Everyone have this ruler and a photo of the moon. So here I have illustrated this thing, and this is my own calculation. There is a full moon image. So just put your scale ruler in front of a crater and in front of whole moon. This is actually I just drawing this line and measured with a scale, just putting the scale or ruler on the laptop screen. But you may good result. You actually if we uh, take a printout of this thing and just measure the diameter with a scale. Here this is 10.8 centimeter. I have measured just putting the ruler on the laptop screen. Without zooming this in laptop, I have measured the diameter of this small crater Plato. So actually printing this image, this gives the good result. In laptop there should be a zoom option. This can be changed time to time. So just print it and take a measurement with your ruler. Uh, I have put here I have measured the diameter as a 10.8 centimeter, and I know the diameter of the moon from previous experiment, or actually you have taken the data from the website also. And this is 3474.8 kilometer, and I have measured the diameter of the Plato crater as a zero point 0.3 centimeter. So just relating these two values, we can get the actual diameter of the Plato. Here Plato diameter is 0.3 by 10.8. Actually 10.8 the diameter of the whole moon. So into multiplied by this actual diameter gives the 96.52 kilometer. And we know actually the diameter of the Plato crater is 101 kilometer approximately. So this is very close result, and actually I have performed this experiment just once. If you perform the experiment few times, I think you will get the closer result of the actual value discovered by the measured by
We have
the
to understand what prime numbers are. What are prime numbers? Okay. So prime numbers are those numbers.
Anyone anything, any problem, sir?
Okay, no.
Are you asking something, sir?
No, sir. No, sir. No
please
question.
carry.
Okay. Thanks. Sorry. So this is the there is also a red line you are seeing. This is the Mount Apennine. I have roughly measured the Apennine as a 2.1 centimeter with my ruler, and calculating this thing, I can get the 675.65 kilometer. We know the actual result is 600 kilometer. So this is also very closer, and I think there should be a very much approximate. Actually, this is not actual result 600 kilometer, because a mountain have a just not a actual distance. So this will be fine, I think. Second thing, in the experiment, see the crater's height. We can measure the crater height also. So this is little harder from this previous experiment too. Just I have to take we have to take the image like this, means we have to clearly clear image with a clear shadow. This is the very important thing. From the shadow, we want to measure the crater height, just like this. There will be a crater. I think I have measured this. Actually, this is not my image. Image is published in BBC Sky magazine. So thanks to BBC Sky magazine. So this actually the crater length is measured with the ruler as a 11.5 centimeter displayed here, and the shadow is 3.5 centimeter. And there also we can measure also peak height, just taking the shadow of peak as a 2.3 centimeter. So actually we need a extra data from a website or a app, Lunar Terminator Visualization tool, and this tool gives the sun angle for the particular time, particular date when we have taken the image. This is a very important thing. So from this website, the author from this actually this image, I think this image, when this image is taken, I have to find out the sun angle as a 4.87 degree. Also for crater there is a 3.66 degree. So using this thing, just calculate like this, tan theta. We know tan theta height by base. So using this thing and we using the angle of sun at that time. So base is the shadow, height is the unknown here. So crater height also we can calculate 2852 meters, 2.8 kilometers. So this is very simple thing. Also here also we have calculate real shadow length. Sorry. So for shadow length we can measure the height of the wall, or and from the shadow of the peak we can measure the peak height. Very simple, and obviously you will ask after my session if there any doubt. So say fourth experiment is the period of rotation of the sun. We know this is a gaseous giant, so period of rotation is not fixed for every portion of the sun. Uh, there will be illustration with for equator. This is 25 days, and to 35 as near about the polar of the sun. So we can measure this thing from our home with my telescope, with our telescope, using the or observing the sunspot. So this is the Galileo's work as an example. Galileo drawing of sunspot June 9, 10, 11, 16, 13. You are seeing that there is a red arrows. The sunspot is moving towards right after 1 day. So just you have to. This is the time of the Galileo's time. So now we have a smartphone. We have a small camera. So just take a image, but every time you should take image with the same magnification or same setting. Setting means just there will be two magnification. One is the magnification of the or zooming of the smartphone or camera. Another is the magnification due to the telescope. So just keep all these things same for several days, several up to just try this experiment for 30 days, but we have no such time for continuation. So don't worry, just take 2, 3, 4 photos, just find out the angular shift or the linear shift, just printing out the sunspot, sun with sunspot, and there should be also same the printing properties, means the margin, zooming, etc. So everything should be same uh, in the time of printing. So just there will be two illustration, and just finding out the ruler. The sun diameter is 9.6 centimeter across, and we have to observe 3 or 4 days or 4 images, because we have to also measure the direction of the movement of the sunspot. So just 3, 4, 5 days, we are able to find out the direction of the uh, movement. So here in a day, that is 13th June, and second image is at 14th June at same time. So at a 13th June, this distance from the one edge, as a we are mentioning here 4111 sunspot number. So this distance is 3.4 centimeter, and just after one day this is 4.2 centimeter. Just take two difference, and from these two length, 4.2 centimeter and 3.4 centimeter, we have measured at 0.8 centimeter in a day. Or it is not very essential to fix the time exactly same at the 13th June and 14th June. Just if we missed the actual time, then no, don't worry. Just take the difference, or take the time in hour, not a day. So let in 13th June I have taken in 8 a.m. and in 14th this is the time is 9 a.m. So this is 23-year gap. So don't worry, just take 23-year gap to move this sunspot from one point to another point. Uh, this is 0.8 centimeter here. Just we have to relate this whole diameter as a 180 degree. So just 180 degree is a 9.6 centimeter. So just 0.8 centimeter is a I have measured here, and sunspot moves 15 degree at 24 hours. Here is a calculation. So just I have measured here for this uh, sunspot. Roughly this region moves with rotate with 24 days. Here this is 26 days, like 26 or 20 or means 20. This region should have the result between 25 and 26 days. So we have measured this is as a 24 days. So this is very fine. Actually, this is rough, not a actual data, actual movement. We are novice. We are a school student. We are college student. So this is very fine for the for us. And actually, this 24 days, this result is not very much important. Very much important. This we have measured several movement for several sunspot in several region. Then we can find out few of sunspot have a movement in 24 days. For few sunspot, this region should have 35 days. So this variation gives the pleasure. We can find out. Second thing is, another interesting is, you can take multiple images for at least 30 days and make a video to visualize the rotation of the sun. But same thing, we have to take the setting same for these 30 days, means setting for telescope and setting for the camera or smartphone. Try to take 5-6 photos in a day. Gives also a good result, means in 30 days if we click the 100 photos, 100 images. This gives a beautiful videography for this rotation of this sun. So this is a fifth experiment. Fifth experiment gives the period and distance of Galilean moons from Jupiter. This will be performed with very 4-inch or 5-inch telescope, reflector or refractor, no problem. And just we have to take, there will be just remembering IO Europa Ganymede have a period with 1.8, 3.6 and 7.2 days respectively. So just 1 week, for a 1 week we can measure this distance or period and perform the experiment. Just we have to take a note. Suppose there is a Europa at the left side, and just you have to draw on your notebook, and at the extreme left position you have to take the time and date, and observing the day by day. We have to wait for the Europa at extreme right, and we have to take the result, means take the time and date for the Europa at extreme right side. So I think this should be 180 degree or half of the journey of Europa. So this this will give the for Europa this period will 3.6 day. So we can guess at one and means you have to convert the in days in hour, and we have to take more data. For IO, this is 1.8 days. So we have to we can measure the period and the distance, but we have to measure day by day. Day by day means just we have to perform this experiment for a night also. We can get the result. This is the experiment 6, occultation. Occultation is special event when a bright object, celestial objects obstacle with the moon, and there will be a lot of calendar there, lunar calendar in sky.org, lunaroccultation.com, etc. So from this occultation event, we can measure the moon orbital rate, that is 0.56 degree per hour. Actually, moon is moving towards east each hour at a 0.56 degree. We can measure this. Just we have to take the here is a occultation of spica, and just at this condition, like this image, we have to take the time and date. Date is not important. This is a few minutes event or few hours event, and wait for total full event, and take the time after emerging from the opposite edge. This should not be just directly opposite, but approximately we can measure the time to travel behind the moon. That is, moon is moving in front of the spica. So just taking this time interval, and we know this moon diameter is 0.5 degree. So just taking the time and degree, we can find out that this 0.56 degrees per hour. And you know, many of us you know the maximum directly, means across the moon occultation. Uh, Maximum time is 1 hour, 1.2 hour, like this. So actually the moon is 0.5 degree and the moon orbital rate is 0.56 degree per hour. So many of occultation takes the time near about 1 hour. So we can measure from our home and for this event we do not need any other special equipment, just a small telescope 70 mm or 80 mm, 90 mm reflector or reflector telescope. Or if for a precise measurement of time, you can use the tracker or for the telescope, and you can take the videography. From the videography, we can find the exact time in a millisecond also. So we can take the precisely time, and we can measure this angular orbital angular rate. There will be a illustration for if there is a no direct directly occultation. Direct means, this is not scientific term. Direct means I want to mention here across the moon. So when the occultation of there is a spike occultation means the emergence and the starting point are the not across the diameter. No problem, I just take the value with ruler. This is 6 centimeter from a image, and this the actual diameter is 6.2 centimeter. So we can find out the angle for angular value for 6 mm, uh, 6 centimeter. So and we can perform this same experiment. Experiment 7 is a variable star experiment. This is a very much scientific experiment in scientific community. Um, Scientists are doing this thing, but variable stars, there will be two type of variable: intrinsic, extrinsic. Intrinsic means actually variable star, and this variation of the variable star means there will be a variation in brightness, and it takes more times, few hundred years or few hours also. So many of the variable stars that can change the brightness in few hours, they are not truly by a variable star, they are eclipsing by variable star, eclipsing binary star. So we can measure a variable star in a day or once in our life. So just we have to measure the brightness. So this is visual observation. This is very difficult to us. So there will be a lot of thing, but we need a very special thing. One is a corrected star chart. After launching the app in smartphone or laptop, many of us do not have any star chart, but this is very essential. We need a star chart. Actually, star chart paper star chart has a brightness guide in the bottom. So this is very important, and there will be another important thing is the comparison star chart. Means the star we are going to observe, uh, there should be another comparison star beside or in a field of view 1 degree. uh, there we we have to know the reference star magnitude also. This is a comparison star chart. Here a lot of marking there. This is a 6, 7, 8, 2 or something. Actually this is 6, 7 is 6.7 magnitude star. 8, 2 means 8.2 magnitude star. American Association for Variable Star Observer gives this type of star chart. So they mentioned there will be not a decimal point, but we have to treat 7.1 means 7.1. So if we want to measure the brightness of any of the star, then we have to follow the side by side star reference stars. So we can just like there will be a written 6 7 means this is 6.7 magnitude. Just below this there will be 10.5 magnitude star. So we can identify the star between 6.7 and 10.5 magnitude. This is very small and smaller than the 10.5 magnitude. So I can think this is a 13.13 magnitude star. So just we need this reference or comparison star chart from the American Association for Variable Star Observer, or also we can download from another type, British Astronomical Association, BAA. So there will be also a star chart. This is a star chart SS Cygni, and this whole thing is a field of view 1 degree. So 1 degree field of view means if you have a 5-inch f5 reflector telescope, then at 30x magnification, this gives 1 degree. So magnification is not very much essential if we are observing bright star. But after 6 magnitude, 7 magnitude, we need a special type of telescope. Means we powerful telescope with more magnification or more aperture size. So this is not very much.
On the first of schedule.
So again, this
One,
is also a star chart. This is
this is
comparison star chart.
example of
So
an
so
expected
we need both these two
system
things.
algorithm.
So from actually this
Check out the bar and
experiment with a
also
variable star,
organization
we
allow
have
you to
to.
download charts and generate light graphs. There's
So actually, this topics is on variable star is very large. We can discuss another day also. So just visit BAA or AVSO website. You can find a great lot of research freely, or you can contribute in scientific community, and or you should have a paper or scientific research paper also. So graduate student, MSc student, or amateur astronomers, or give doing this experiment, you can also do at home. So this is my addition using a smartphone. Actually, using a smartphone means I am mentioned here is a app, PFOX. PFOX is a great app for scientific experiments at home. So there is a lux meter. uh, so using a lux meter, you can also compare the you can check also the brightness of the variable star. The lux value is not very important, but suppose the reference or comparison star have a 10 magnitude, and I have find this is a 7.0 lab. So if we are seeing the unknown variable star, and using the smartphone, this gives the 30 lakhs. So just using these two fellow, we can compare in the magnitude. This is 70 as a 10 magnitude. So just 30 as a different magnitude. So just you can use this lux meter uh, your using your light sensor of the smartphone. So just check it. I think this would be possible. Experiment A is very interesting, measuring the temperature stars. This is actually a rough measurement. So just actually we know the colorful stars have existed. If the star have a blue light, and means this have a higher temperature, and red means a dying star, means a lower temperature. So just visualizing this thing, this is very difficult to identify which is very much red, which is very much blue, and just compare. But if we want the scientific result, then use the three filter. blue, red, and green. So if you use these three filter and just use this filter and take the brightness with your smartphone, and we have to compare this the intensity of three using three filters, just like this. So this is a graph. This is a graph. So for a graph, we need a stellar spectroscopy. Spectroscopy is very much costly. So we can get rough result. Suppose the intensity is 70 for blue light or 30 for red light. So we can easily say that this star is a blue star. Blue type star means this temperature is 28,000 to 50,000 Kelvin. So this is a very easy trick, I think, very much easy thing. Or this is spectrography result, and so we are using the Wien's displacement law, and this is a good project for a graduate student also. So for this we student need special guide from the teachers, or we can discuss later. But for a stellar spectroscopy we need a spectroscope. But I performed a experiment with just a grating of cost 500 rupees from Amazon. So this grating also gives you a good result, but I especially unable to see the absorption spectra. But you can see the absorption spectra if you attach a small special telescope, just like a spectrometer. Uh, we can, I think, we can able to see the spectrographic absorption spectra. But I think I have measured the continuous spectra for Sirius star. So for different star, we can get different continuous spectra. Different means the intensity of blue light, intensity of red light, intensity of yellow light is different, but all are continuous. For just placing a grating in front of the eyepiece of your telescope and just view. This is actually, in this illustration, this is reflected light from a grating, but you should not observe like this. This is very difficult in opposite direction towards the telescope. So just place the grating perpendicularly in front of the eyepiece, and direct light you will get the white light, but after first maxima, second maxima, third maxima, you will get the continuous spectrum. So just take the second or third continuous maxima, and you will get the continuous spectra. Or if I will I asking you, all of the students, you may also perform uh, this continuous spectra for to measure the uh, temperature of the star. Means a image, a continuous spectra have a brighter brighter portion in the blue light. So this is we can roughly treat it as a blue star, but maximum intensity distributed in the red star. So red light, so we can treat as a red giant. So this is the very complicated experiment, but you can try. You can try. This is important. For stellar spectroscopy, this is advanced illustration. If we are able to buy a special type of spectrometer for the stellar spectroscopy, then we can able to see the absorption spectra. There's a black line in this image. And so for from this absorption spectra, we can determine the elements in front of the star, that is the star light coming through a nebula or something, then we can identify the material or element in the nebulosity or nebula. So this is very important in scientific research. So this needs a special spectrometer, and we need a special software for this also to analyze this the absorption spectra. But you don't have a telescope. Many have a telescope, but everyone do not have a telescope. So don't disappointed. Don't be you can go through the website universe.org. There will be several projects, not only the in astronomy. There will be a biology project, there will be a chemistry project, a lot of projects there, and these are scientific projects. You can perform through your laptop, through your computer, and you can give a scientific report to this website through a proper process, and there this if you uh, done the good job, then they can publish in their website or journal. So this is a very easy and very much scientific for the enthusiast. Another website is the asteroid search program, international asteroid search campaign. So just visit also iasc.cosmosearch.org, and this gives you a there should be just a process. You have to mail this uh, instructor director for the campaign, and you can perform, and this gives a good result. This is a another citizen science program, and anyone can perform this program through rad@homeindia.org. Professor Ananda Hota is a director or instructor of this project. This actually this is the data from coming from GMRT, Giant Meter Radio Telescope, the global giant telescope, biggest telescope, radio telescope. So you will just trying to do scientific research. So no problem, just go visit this site, and there will be a lot of process. You have to give the training through Facebook or any other group meeting, and after training you will be able to do some RGB analysis. And so after your performance, there should be a astronomer certificate, and we will be grateful just like astronomer. So this is very much important and very much scientific citizen science program, and you are also a chance to visit our this GMRT telescope site. So this is a very much opportunity. Those who have no scientific communication, scientific engagement, just like you are a teacher, you are a just a science lover. So you go through this website and go through the scientific experiment. And thank you all of you, the mainly for the listeners. And I think if there are any question, you are you ask.
Thank you very much, Gopal sir, for giving this illustrious talk. Now we invite all the participants to raise question if they have. We don't have any question in the chat box, but participant can raise question directly to Mr. Gopal.
I just want to ask a small question.
Yes, ma'am.
I just want to know, one second.
Yes, ma'am.
What I want to say is, you said that we can those crater measurement of the moon with the help of a ruler. Okay.
Okay.
In the beginning, you showed us those images. Suppose the image is small, then again the measurement will be small also. No, in that case, How can we do? What will
we,
be the?
we have to take print out in bigger size. Just take the images as well.
Yeah.
There is a postcard size image, but if we print this image in a larger page,
Okay.
this gives the good result.
Okay. I was. So you had. Is there any particular image that we have to take, or is it any image you can take for the crater measurements?
Just visible outline. You can take a photo with your smartphone using your telescope.
Okay. Okay. Thank you. Thank you so much.
Just should visible the outer edge of the crater.
Okay. Thank you. Thank you so much.
Okay.
Sir,
Yes,
Yes.
yes. Go ahead.
sir, I don't have a telescope, so how do I calculate the moon's diameter or so?
Just follow the first slide. Okay. Just take a yes, you have also a solution. You don't have any telescope. Just I am showing you this slide. You don't have a telescope. Just fit a narrow pipe, narrow PVC pipe with diameter 1 inch or half inch, and fixed uh, on the bottom side of the protector, and whole thing, and yeah, this a red thread here mentioned. So just put this thing on a tripod or a stand, then take the rough image of two side or up and down of the moon. So just make a telescope. Just this mini clinometer also give you result. Or after
Okay,
certain
sir.
time,
Thank you, sir.
after certain time you should buy a small telescope. Thank you.
I think, Mandal sir, we have to give one warning to young kids here that we should not look at sun directly through any telescope
Yes. I mean,
unless we have
say, sorry.
a proper protection or filter to view the
We
sun.
need a special sun filter for this. No other way, no carbon copy, no X-ray plate. Just use a proper solar filter for a telescope.
And how would you
Thank you,
recommend, sir? How would you recommend to take the photo of sun through the telescope?
just using a solar filter, and just put your phone on eyepiece, and
Okay.
there should be a patient, because uh, this is not too much easy, but I think junior students are a very good photographer also, so they can take the photo.
Any other question? Tushar Prohit sir,
Sir,
yes,
Yes.
sir, the spots keep
yeah.
changing every day and like every week. So how do we measure the distance they'll travel over one day or a period of time?
Sorry, I just missed the first line. You have said
Sir, we were taught that the spots move every hour or every day on the sun.
sunspot. Okay.
Yes, sir. So how do we measure the distance they will travel in one day or two?
Just
Like you just told. So
follow this image. Are you seeing this image?
yes, sir.
We just this is rough calculation, but we have measured this with ruler.
Okay.
Okay, just taking ruler and find the relation between the actual diameter. So we have to measure two result, means movement of the sunspot with ruler and the diameter of the sunspot with ruler. So just compare these two things.
Okay, sir.
Okay, thank you.
Any other question?
Yes, sir.
Hello.
Sir, how
Yes.
can the distance of the moon we have measured from the scale be so accurate?
Actually, then we have to use a special telescope that have a setting circle, just like a setting circle. This is my homemade telescope, so I am showing you. The right image. There will be a homemade telescope. This is my homemade telescope at my observatory. So I have put here a circle with a degree with 0.5 degree change. Sorry, 0.05 degree change. So means 1 degree have a 20 division. So just we have to use a larger telescope or telescope with a larger magnification, but we need also a setting circle with more precision. Then this gives better result. If we take the 1.5 degree,
अन्य की दुकान में बात हो सकती? मैंने बात करा है यार. Okay. Sorry.
Yes, any other question?
Shall I add something in this?
okay, sir.
Tushar sir.
Hello.
Yes, Tushar
As
sir.
he
Yes, sir.
mentioned, as he has mentioned, you have to put the setting circle and this thing. The precision is required more. The best thing while observing through the telescope is having a particular field of view. That is, if you are using a 6-inch FX telescope and using a 25 millimeter eyepiece, it will end up with a
Yes,
1
sir,
degree
yes.
field of view.
Yes, sir. Yes.
Okay. So while observing, you can match a moon.
Field of view.
Moon is traveling
Yes.
in the field. Okay, that is moving from west to east. So you can use a stopwatch. Okay, and the field of view is basically you can measure the time, and with the help of the time and divided by 240, you can get angular size of the moon, and you can calculate the diameter. Easiest and simplest method, and
Yes, yes,
this
sir. Yes,
will
sir.
be
Thank you, sir.
helpful for the and this is helpful for the lunar occultation also. So
Yes, sir. Yes, sir. Thank you. Thank you,
try
sir.
to be a practice. If you can match the field of view, this thing, it will become so easier. Okay, you don't require the setting circle and nothing. Just all the things start and the time. That's it. So it becomes a simpler,
Thank
and
you.
you can get a very
Thank you, sir.
accurate
Okay.
in this.
Yes, yes, sir. Yes, sir.
Overall, the things
Just
are
you.
good. Yeah.
Yes, sir. Yes. For I will include your opinion in the next slide, next discussion. Thank you, sir.
Yeah. So you don't have to put the setting circle for the telescope. It's a minor.
Yes.
Measuring this
Yes.
particular angle might be difficult for the newcomers or the beginner.
Yes. Yes. Yes.
So
Yes.
it's
Yes, sir.
easier to measure the timeline.
Yes. Yes.
Thank you, Mr. Tushar.
Thank you. Thank you.
Thank you. Yeah.
Any other query? I will request Professor P.K. Aluwalia sir to give his remarks.
In fact, I was too late to join this. However, I think this has been a very useful lecture, and I was stuck with some other task. I have missed it, but definitely I will come back. And the title of the talk was very attractive, for me also, that I should have watched it, that how to make use of a telescope in a very, very effective manner. We talk about very many other things, but forget about that telescope is the most fundamental instrument available to us. So I would just like to thank
Thank you, sir.
Dr.
Thank you,
Mandal
sir, for your time. Actually, I am
and,
a member of RC15, but
oh,
I
okay.
cannot. I can join your meetings. So first, I
Yes.
here. Thank you, sir.
So welcome. In fact, please be with us more often. I think we are able to run NASNI only when more and more people join us. And I'm glad to see that you are part of an astronomical group in West Bengal. That's great.
Yes, sir.
That
Thank you,
was one of the things. And as IAPT president, I would love to encourage IAPT members to come forward and participate in this NASNI because it's a great thing which Dr. Hemant is actually carrying forward with a lot of dedication and with discipline, rather, I would say. Thursday, Wednesday means Wednesday, and a lecture has to be there. And I think the number is around 40. I don't consider it as a number which is less because very many other people go and watch it on the YouTube also. So, Gopal, please keep on interacting with IAPT because IAPT
yes, sir.
runs
Yes,
when its members actually help IAPT. And I
yes, sir. Yes.
express my gratitude to you for coming and giving this lecture. And thank you,
Thank you, sir.
Hemant. It's so great. It's just wonderful.
Thank you so much,
Thank
sir.
you.
Thank you. Any other comment from Dr. Reshma or Dr. Kaustubh?
Yeah, hello, sir.
Hello, madam.
Yeah. So it was really nice, very helpful to me as well. Uh, I would say, I would put it in this way. Having a telescope is great, but again, we have been only using it directly to see view or something like that. But now knowing how to use it, I mean, how to use it for doing experiments, I think that has really helped me as well to do some experiments with this. Thank you very much, Gopal sir, for this wonderful
Thank you.
session.
Thank you. Thank you, madam. Thank you.
Dr. Radhika, you want to say something?
I think you have muted, sir.
Okay. So we don't have more questions in chat box even, and nobody is coming forward for more questions. So on behalf of NASNI, I want to thank Mr. Gopal Mandal for sparing his very important and precious time for this group and sharing his knowledge of quantitative measurements using small telescopes at home with all precautions. I must say to the young kids here. And lecture was really very nice to with a lot of takeaways for all the age groups of this members of this group. I have also learned so many things, and I will try to measure size of moon by the tricks you have given in this talk. So once again, I thank every member to join here, especially uh, um, all senior members and from the members from Nagpur, Professor Rajinder Singh, exploratory, and the number is good, and keep in touch, and I must say that join us in the next talk on first Wednesday of next month. Thank you very much, and let us close this session. Thank you and good night.
Thank you. Thank you, sir. Thank you.